All right, I'm David Siegrist, longtime Presbyterian. Had a number of jobs at churches, to include being a trustee, a deacon, a lay leader at a certain point. I work for the MITRE Corporation now, but anything I tell you will be my own opinion. I don't think MITRE has an opinion on anything we're going to discuss today, so that's an advantage. I have a PhD from George Mason University in Biodefense. What I was doing on that had to do with statistical anomaly detection evaluation. So what that means is that in time series data, you're looking for what's surprising, what's mathematically out of sorts that needs to be explained. I've been teaching a series of classes for the Wrestlers class here on science and religion. I've been asked, are you a real scientist? And so I would say that, well, I've been published in a peer-reviewed journal, the Morbidity and Mortality Weekly Report of CDC, a special edition, on statistical anomaly detection evaluation for early warning of outbreaks of disease. So what they were trying to do in that is to actually predict the future, to so that if you look at the stock market pages and you see Apple is going up, will it continue to go up or will it revert to the mean? Okay. That's something like what you try to do when you're looking at case counts for outbreaks of disease. And so trying to predict which upswings are going to continue and which might revert is a trick, and we had some real smart people working on it. And so I happen to be actually in charge of the evaluation to try to say who was doing a better job, whatever, and that got published. And it's, according to ResearchGate, that's been cited about 50 times. So I make claim to be a scientist based on that. Okay. And as I say, been at the church for a while, teach wrestlers classes. So I was very pleased when Quinn asked me to do this one on relatively short notice for me. Any questions before we get started? Go for it. Okay, I like it. Okay, so I thought I'd give a course plan. I got 3 weeks, so here's my plan. So I'm going to try to establish that there was a beginning. And if there's a beginning, then you have to justify, or scientists would like to justify, why did it start then? Wasn't it always there? That sort of thing. And if it did start, then how did it start? And then what implications does that have? Because it didn't start by itself, presumably. Okay. So next week, I'm going to make a little bit bolder claim that the universe seems to have some sort of purpose. And the way I approach that is saying that if you take a look at processes that go on in the universe, they have an output that's measured a certain way, and that output seems to show a central tendency in the data that goes up, apparently by a power law, right? Across eons, across different modalities, that is, from galaxies to plants. So I look forward to telling you about that next time. I will say that this then runs counter to what we normally hear in the scientific community from the big swingers, like Steven Weinberg, who says the more we take a look at the universe, the more it seems pointless, right? So if the universe is pointless, doesn't that have philosophical implications for all of us? I will say that my limited experience and interaction with the Harvard faculty is that they still care about their grants and where their kids get to go to school, right? So in operational terms, I don't think they're considering that the universe is pointless. Their part of the universe, they take very seriously, right? And so I'm going to say that as a general rule, if the universe has a central tendency, then it's trying to do something. And so that implies to me, perhaps if there was a creator, there's a purpose. Okay? Where do we fit in? Okay. And then I suggest, finally on the third week, that humans have something to do with the purpose. That's the plan. It's ambitious. And I will say, I'll give another caveat. I do this as a hobby, right? So that, and I sometimes have very astute students, and I'm glad to interact and learn from them if they have a good point that they want to do that. Okay. Creation of the universe. Didn't it always exist? If it always existed, then you don't really need to explain it. How did it get here? It always existed. And that was the point of view of Aristotle and all what I would call the smart money, who used to, I would say, laugh at the Christians and the Jews who would say, oh, God created it. They're like, oh, it always existed. You know, you're just saying that, you know?
Doesn't that put us in the same situation where we say God always existed? But, you know, when you get into an argument with people, they might argue the universe always existed. God created it. Where God come from? Oh, God always existed.
Right. So that you have to somehow get back to what always existed. And I think if you hold that particular question, I'm going to try to address it in a little bit more organized way. But if I don't, please remind me. Okay. So very relatively recently, in the 20th century, then scientific evidence became available that indeed the world didn't always exist and that it had a start point some 13.8 billion years ago. Okay? And part of this was that faraway galaxies seemed to be receding from us at a great rate, and that also there's cosmic background radiation all around us distributed in a very even fashion that would be consistent with a huge explosion ages ago, and that this would be the remnants of it. I'll just mention that the Catholic Church, for one, has endorsed the concept of a Big Bang start. So it's not anti-Christian per se to believe in a Big Bang. Okay, and actually a Catholic priest was one of the main discoverers and of this particular point of view, Francis de la Maitre. Okay, so that if there's a beginning, then it's more likely that there's a creator. Okay, so I'm going to spend some time talking about the fact of, was there a beginning? So the Big Bang and creative destruction. Usually we expect to blow up something and get nothing, right? So this is a very unusual explosion in that you have nothing, there's a huge explosion, and then you have something. So that fact alone, I think, needs explanation, obviously. And it not only was this initial Big Bang, but it continued to grow and engender additional structure and other things such as life. How did it do that? The main theme, I guess, of the Big Bang and the universe subsequently is taken up by the second law of thermodynamics, which has to do with entropy. Entropy is increasing disorder. So energy is not destroyed, however, it becomes less useful, becomes more disorganized, and it can't do useful work. And that's the story of the universe writ large. Entropy, winding down from this huge explosion, the so-called Big Bang. Nevertheless, even though the whole world is winding down and will eventually, supposedly, end up in frozen nothingness in heat death, there's a significant sub-theme, which is the buildup of complexity and structure, right? And I think people sitting in this room are examples of the buildup of complexity and structure. So the world is winding down, but the sub-theme is there's a building up of part of it. And I'm going to talk about that in more detail. So that I believe these observations are consistent with a creator and a purpose, right? So that if there was a Big Bang and somebody created it, if I can try to demonstrate that in the next few pages, then makes it likely that there's purpose to it and that we somehow play a part in it. That's my thought. Howard.
Can you take a question now? Do you want to hold questions later?
I think now is a good time for a question.
So I understand that the Big Bang was a theory that took a while to be accepted. So when you comment in the second bullet here, scientists often say that it was a result of a singularity because the rules of physics break down. So when a scientist accepts the Big Bang and the redshift and this sort of thing, are they also accepting that the rules of physics broke down at that point? Otherwise, the rules of physics work, or physicists saying something different.
Okay, so I'll repeat the question for the folks that are streaming, and I won't say the whole thing. Hello, but tell me if I do violence to your. Okay, so Howard's question had to do with then, do scientists accept the Big Bang? And he believes that it goes back to a singularity in which the rules of physics break down. And I would say that yes, that's the mainstream belief. And I'm going to talk more about it over the next couple of charts. Miss.
Would time be one of those things that breaks down, or has time always been?
Time is one of the things that would break down. Okay, so that you've probably heard of space-time, and that time is the fourth dimension. Okay, so time is intimately involved in space and the three dimensions, so that the scientists believe that time started when space started and energy, so that then you would tend to be looking for something that is timeless to cause time, right? Or something that transcends time to cause time. And I'm again going to talk about that in a little bit. Okay. Review of the Big Bang. So there has to be, to have complex structure where I'm going, you have to have some matter, some material to manipulate. If you ever try to manipulate energy, it just doesn't take as far as structure is concerned. So as we know from, here comes an equation, E equals mc squared, right? So that matter could be considered by the non-specialist as a congealed form of energy. There's a lot of energy that makes up matter, which is why, for instance, in the atomic bomb, you had like a regular bomb of some kind, but that it had such huge explosive power because basically it was turning some of that matter and releasing it as energy. Okay? So different from normal weapons, that type. So that it's another thing that has to be explained, I would say, is why energy has the property that it can also come across as matter. Okay. Now, if we have physicists around, they'll say, well, that's just the quantum spin and the Planck, and that one is even and one is half spin. That's nice. And if you didn't understand that, that's okay. Okay. But then the idea with the spin is that this is a digression. For a circle, how many degrees are in a circle? 360. Okay. How many are in that full integer spin? 720. So it's not just normal spin, right? I'm just trying to throw that out and say it's not that easy, right? It's a very complex, exquisite kind of thing, the difference between matter and energy and the conversion from one to the other. However, I'm saying that at the beginning, at the so-called Big Bang, you get, let's see if it works. Kind of. So big explosion. And so there's huge radiation that's dense, okay? Huge radiation, hot, dense, expanding very rapidly, right? So that for the first 380,000 years, no light comes from it because the photons can't escape the radiation. So I was just talking to Professor Unger earlier and just saying that the Hubble is out there. It wants to go back to the start of time, but it will only go back to 380,000 years after the Big Bang, because that's when light could escape. Okay, huge, dense thing. Now it's expanding out more, right? And it's expanding, it's cooling. And so then these particles start to, what I consider, precipitate out from the cooling, expanding Big Bang. So these form some basic forms of matter to include, let's call them quarks. Okay, quarks congeal into protons and neutrons, and eventually the thing cools off so much that these positive forces with the protons can attract electrons and become atoms, right? And atoms make up material. Everything we know of as matter today, made up of atoms. And then, jumping ahead, the atoms then that are close to one another are drawn together through gravity and form things like stars, planets, the observable universe. Okay? So that's kind of the thought process behind the Big Bang.
Maybe it's just my own fitness. How big was this thing that had the Big Bang?
The thing that the Big Bang.
And where did this thing come from? And I cannot grasp conceptually there being nothing before that. I just think.
Oh well. We're yeah. Okay. We're gonna have a time, because once I start to talk about the different kinds of nothing, you probably really get lost. So we'll need to deal with that. Yes. But what they suggest, okay, let me back up. Okay, there's two major groups of theories that the 20th century produced on physics that are just phenomenal as far as their ability to explain and predict behavior of these particles. One is gravity and one is quantum mechanics. They're both wonderful. You can check them out to 5 digits. Wonderful. Very successful. Okay, they're not compatible. They use different kinds of equations, for instance. Not compatible. So then right now, what the physicists are trying to work on is something called quantum gravity, right? Quantum gravity. So the idea would be, at very close distances, how does gravity behave? And so the idea of the Big Bang and the singularity that you mentioned is that all this energy was, I'll say, congealed into such that the submicroscopic effects dominated and quantum mechanics played a part. So it was real small. So trying to figure out how that could happen is well, they asked Einstein, about space-time, and he said, well, it's hard for me to imagine. So when I think about it, I like to use mathematics and get into extra dimensions. So I've not had that privilege to do that myself, but that was how he thought of it. So you're not alone. You're not alone on that. And Richard Feynman, the Nobel laureate, said nobody really understands quantum mechanics. And I think that was the context in which he was thinking that. But what we're talking about for the Big Bang, again, is a singularity where the laws of physics break down, but that immediately after that, all the laws of physics were in place. So that these smart guys, and ladies, obviously, will take time back to what's called Planck time, which is 10 to the minus 43 seconds. Okay? So 44, 42. That's when they say the laws of physics they can go back to. But before that, they kind of shrug and say, well, we sure wish we had a good theory on that. Okay? So then the question becomes, how did that happen? And that's why we're here. I have some thoughts, which I'm sharing. How we doing? Keep going. Okay. Right on. Oh, okay. So are atoms part of, okay. So I mentioned the fact that it created a particle zoo, from which we're all made and which is out there. But I just wanted to reemphasize the idea of mass energy. So that with all these atom smashers, like the Large Hadron Collider and all these, they're throwing particles together and creating huge energy in the laboratory, in effect, right? They're creating particles, right? It's not the fact that they were breaking up something and revealing particles. It's that they put a lot of energy together. They create an outburst of energy, and that forms particles, what we consider particles. Then you'd say, well, particles, what do we mean by them? You know, it's a wave function in many cases, whatever. So we can't get too concrete about that. But basically, you're creating matter from energy in the atom smashers. So again, the interplay I believe needs to be explained why it would do that. I don't think it's completely well understood. Okay, so I'm now going to try to emphasize the case on why we think there was a Big Bang. David.
Oh, man, I know that the Bible is not
Right.
but during a short period of Genesis, what would be the rationale that light started first? It seems to track to this, right? But would that be sort of a commonly held belief that if we were creating something, we would create light?
Oh,
This is electromagnetic energy, light, sort of go back. That's sort of the first thing in creation. Is there something there that's sort of like tracks it all?
okay. Okay, so we have a question in which the questioner is talking about the fact of, in the Bible, it indicates that light was created early on, right, or first. And does anything track with that? So light, as you're familiar with, is carried by photons. And so there's huge photons that's part of the radiation in the initial Big Bang. So I would say it tracks. The light was not able to escape, as I mentioned, for 380,000 years. But while we're sitting here, we're being bombarded with photons. Okay. And somebody said drive on. So here we go. How am I doing on time? Oh, perfect. Okay. So galaxies are made of the same stuff as our solar system is. And so there are different frequencies that the atoms have that they emit light at different frequencies so that we know what characteristic frequencies are. And so as we look further out, we can see that the hydrogen and helium that are in faraway galaxies are receding from us because they are so-called red-shifted. That is, that their radiation shifts to the right, to the red in a part of the spectrum. And so by doing that, they're saying we're in an expanding universe where it's actually space is expanding. Okay? And getting back to different kinds of nothing, how space is expanding is exciting concept to consider also, right? Okay. So that one way to think about it would be, as I tend to say, would be raisin cake that's rising, you know, like the night before or something. And all the raisins in the cake are getting, in the dough, are getting further and further from each other, right? As the dough, in this case, the analog to space, expands. Okay? So we're seeing everything receding from us, but that doesn't mean that we were the center of the universe, because everything is receding from everything else because space itself is expanding. One of those, okay. So if you then run backwards that tape of everything expanding, at some point it appears that everything was very close together indeed. So that's considered evidence for the Big Bang, what's called the Big Bang. In addition, there's cosmic background radiation, which we could think of in terms of recently, I guess, taking a turkey out of the oven and putting it in a cooler room, and that the room gradually gets warmer from the radiation from the turkey. That's what I can do with that. The background radiation was predicted before it was discovered, and the guy said it's going to be in the microwave frequency spectrum, and that it should be about 5 degrees. And so then these two Bell Labs scientists found it. It was 2.7 degrees. You know, so they fixed it, fixed the theory to come up with that. So this is also thought of as a reason to believe in the Big Bang, or a start, in that in every direction there's isotropic cosmic background radiation at 2.7 degrees. The Bell Lab engineers originally found it because they were trying to get that little hum out of the back of their radio transmissions. And then they discovered it was all around, and it was a real true fact.
What year was that, more or less?
I'm sorry, 1957, I'll guess. Just guess. Okay. Okay, so I hope I've established that there's reason to believe that there was a Big Bang, and that the universe started at about 13.8 billion years ago, or at least that's why scientists believe that, right? They have evidence toward that. And that energy, matter, space, time all started, okay? So that if we think that that is when they started, then something caused it to happen, and presumably that would not have anything to do, or at least be transcendent of, space, time, energy, and matter. Okay, so as I put it, no matter couldn't cause matter, etc. So what I call a causative entity would need to transcend time and space, and it would be something immaterial, timeless, powerful, and purposive. And I say purposive, if the universe was created, presumably it was created with a purpose. What purpose? Because it's quite complicated, as we've just kind of indicated, right? And that the purpose of created suggests the contention of a personal God, one who acts for a reason rather than some sort of impersonal cosmic forces playing out somehow. And again, some scientists say that scientific laws are enough to start the world. However, as Stephen Hawking put it, what sets fire to the touch paper and breathes life into the equations? And he spent his career trying to answer that question. Okay. Now, I sometimes have fairly very sophisticated people listening to me sometimes, and get a range. And I'll just mention the fact, for completeness, that there are several theories then that try to get around the Big Bang, or talk about what happened before the Big Bang, to include eternal chaotic inflation and the string theory landscape. And I'll just kind of, for completeness, I'll just mention it and just say that anything that's inflationary, then according to Vilenkin and the, may I say, the Board, Guth, and Vilenkin paper and others, Guth helped to invent inflation, the concept, that anything that's inflating has a beginning, So I'm not planning to go into these in any detail, but just for completeness, I wanted to say that anything that's inflating, and we're inflating, it's expanding out, has a beginning, because you run up into the special relativity law and the speed of light, which I'm probably not going to spend a lot of time on. Okay, so that's my contention. What are your thoughts?
Well, before we get into that, you make a reference there to Science Uprising #3, something from nothing. Where can one get a hold of that video?
You just Google it. Yeah. Yeah, I want to give credit to them. I thought that was, they played it well. Okay, all right. All right, so moving right along. Okay, so moving along, a funny thing about creating through a Big Bang. So when I first was looking at this, I'm like, oh, well, it just happened to be a Big Bang. Yeah. But looking at it a little closer, I'm like, what does the Big Bang give you, right? If you choose, if we believe that there's a start, that it's a creation, therefore that there's a creator, why did the creator create through a Big Bang instead of a static creation, which I refer to as a doll's house universe? Why have this big kinetic rock garden, right, going on for billions of years, you know? Okay, so with the Big Bang, you create a heat engine. So I've mentioned the fact that the Big Bang, large energy, entropy winding down over time. So as heat dissipates to a colder environment, it is able to do work. Okay, and so we can think of this like a steam engine where you heat up water, it becomes steam. Steam drives a piston, and the piston takes you down the road, right? It creates useful work. And we can think of this in terms for the Earth, for instance, from the sun, that the sun is bombarding us with photons, which these nice little plants capture in their photosynthesis. It displaces electron, which then they can reuse to have energy to drive cells, which are vital for all forms of life. Okay, so I would say that this then indicates that there's a continuing act of creation, because there's matter, something to work on, and there's a heat engine that's supplying energy, that's moving through, that is, and I'm suggesting that that is a way that you can, that is a mechanism by which a creator could continue the creation to create more complexity. That's where I'm going with this. Okay. Yes.
So when it comes to the possible existence of other planets, do scientists believe that the same mechanism must occur for other planets to, or other solar systems to arise, or is it conceived that there's multiple mechanisms?
Okay, the question was on life arising on planets, and there's so many. Okay, so there's I forget the title of them, exoplanetary biologists, but anyway, that's a lively question now, and so they're trying to strip down the fact of what do you need for life, and life is so abundant here and so rugged and so defying the odds. I mean, there's a bacteria called the radiodurans, which actually likes radiation. You know, there's bacteria that like to hang out near volcanic vents. You know, who knew? They found scum on the outside of the space station. It's a lot. It shouldn't be. It is a lot. Okay.
So they don't know whether a Big Bang has occurred in other solar systems.
The Big Bang takes care of all the solar systems. Okay? So that we can look, whatever we see with a telescope, the scientists are claiming it all came from the same Big Bang. Okay? And that all the physics is the same, which is why the radiation at different frequencies gives the scientists confidence that they can measure what's going on, I don't know, Alpha Centauri, the same way it would be here. So they're doing that. Whether life would take the exact same form is the open question, but life happened here, and it happened relatively quickly on Earth. However, it appears to only happen once, and we've been looking for extraterrestrial life for a long time and have not found evidence of it. And so that's like a mystery. Like, if it happens here and it happens quickly, why haven't we heard from all our colleagues, you know, around? And that's one question that's being explored.
Do you have an opinion on that, if there is extraterrestrial?
I believe there is, but it's not clear because of the size of the universe that we would ever be able to contact them. And sometimes people say, well, if there were spacemen, what are the implications for Christianity? I don't think there's really any. You know, I mean, spacemen are okay by me. Somebody asks a pastor, and he said, would you baptize an extraterrestrial? And his answer was, if she wanted me to. Okay. Oh, excuse me. Okay. So any thoughts on why a creator might create this way? To have a continuing creation rather than a static creation? Sir?
It seems like that, you know, the very I see in the Bible that God enjoys his creation.
I'm sorry, I'm not hearing you.
God enjoys his creation. God enjoys the act of creation.
Yes.
He enjoys us forever, we enjoy him forever. So it's a symbiotic sort of joy of creation that is evident.
Oh, okay. So for the viewers, the question was the comment was that God seems to enjoy creation, wants to continue doing it and interacting with his creation, and I think that's true. If we look in Job, right, and Job is mad, you know, and then finally God says, "Where were you when the stars were born?" and goes through, if I recall, 28 different things that he did. And to me, he's showing pride in his creation. And he's like, when you can take a seed and turn it into a spruce tree, or when you can make a mackerel out of nothing, then we can talk, you know? But he seems to take pride in his creation, not just humans, but the whole thing. And if we look at it, it's amazing, right? It's awe-inspiring the more we look. So that's one approach. We'll continue to, I think, to entertain that question. Sir?
Well, I mean, we're told that we were created in the image of God, and we enjoy things that God has created. For some of us, it might be seeing a whole forest of trees in depth, laced with snow and things like that. So if he gives us this ability to enjoy things in creation, I guess he must enjoy a few things himself.
Seems very reasonable. Sir?
Tell me again what you mean by static creation. It seems to me that the reason for speaking about this dynamic process is it's what seems to be what scientists are discovering, but it's also biblical. I mean, the first chapter of Genesis is an evolutionary process. It isn't on one day, boom, there it is.
On 6 days.
Yeah, well, I mean, if we consider a day as an eon of time,
Right.
then it's over. It's a process that unfolds, right?
Okay. So for the viewers, then I'll just say that gentleman suggests that the dynamic creation is biblical in that it took God 6 days in the Bible to create, and that he created different things at different times, sort of progressively. Sure. Okay. So I've tried to establish that the universe started, it was created by something outside itself, that it's a dynamic versus a static set-piece world, and that the creator has ensured that there were a number of particular mechanisms in place to enable enhanced continuing creation. And so that's where I'm going now with the next couple charts. So one of them is gravity. So that we have this, what I referred to inelegantly as congealed energy, matter, that's precipitating out. It's drawn to itself through gravity. Did gravity have to exist? Don't know, but it's there. And so by enough stardust or enough cosmic dust coming together, it tends to form stars. If it's big enough, then the gravity weighs in on all this matter, right? Weighs in on all this matter. And at the center of this, there's tremendous temperature and pressure. And that after a while, then the temperature and pressure is such that it causes atomic fusion, the same power that's in the hydrogen bomb, right? And that you have the stars then ignite and form stars, which then they have planets circling around them and offer the opportunity, for instance, for life by heating the planets that are closest to them. Right? So gravity is responsible for galaxy formations, for stars for planets and solar systems. So gravity is a big swinger. We like gravity, right?
How do black holes fit into that?
Gravity gone wrong. If there's enough matter that comes together, instead of forming a star, stars can fall into black holes. And so black holes have so much gravity that not even light can escape from them, hence black hole. But there's a huge black hole in the center of the Milky Way galaxy, for instance. So they're around there. And black holes are kind of interesting for theoretical physics because that's another place that gravity and quantum mechanics come together. And it's a fruitful area of research. Okay. So the other point that I wanted to make was about molecular bonding. So I hate to anthropomorphize it, but the atoms like to have, like in this case, 8 electrons on their outer shell. So in this case, sodium has an extra 1 electron out here, whereas fluorine has 7. So basically they get together and the sodium fluoride and the sodium donates the electron to rotate, as we think of it, around the fluorine. And this binds the two together into sodium fluoride. Okay, so this works for lots of things. I've referred to it as this, the Lego system, so that there's 92 natural elements, right? 92 or so. And, but together by bonding, you can make even 100,000 molecules out of carbon, just as an example. So all the wonder that you see around you, all the wood, water, air, whatever, made of molecules. So that from a fairly limited beginning, a set of 92 elements, you now have a tremendous amount of structure and complexity that forms in part because of the magic of molecular binding. Because it's a lower energy state for the molecule to be able to share those atoms in its outer ring. And so, especially carbon has 4 electrons in its outer shell, so it can actually combine with itself, and it does. And it can make lots of things. Here we see the examples of plastic, motor oil, diesel, gasoline, but also things that we need for life, to include amino acids, carbohydrates, complex sugars, starches, lipids, nucleotides. Okay. So carbon is very important. I'm giving that as an example of something that is, I'll say, leveraging this molecular bonding proclivity that is inherent in the chemical world, right? And I'm suggesting that this is another mechanism that is in place. And did it just happen? If we believe that there was a creator with a purpose, then we're saying this is a peculiar kind of universe. It was designed for a purpose. This is part of the mechanisms to make it work out, is a contention one could make. I am now going to pivot slightly, and I think time is winding down, and talk about and try to reinforce that this is a very special universe, and that the place that a super intellect, super being might have as a creator. So that there's approximately, let's say, 20 physical constants that are incredibly finely tuned, and they interact with each one another. They're mutually dependent before you can get the kind of universe that we have. And that if they weren't all precisely fine-tuned, we wouldn't be here. Let me give you an example. So in this chart, this is talking about the fine structure constant and the strong force. Okay, so in an atom, in the nucleus of the atom, there are a bunch of protons. Protons are positively charged. From a rudimentary point of view in physics, what would we expect of a nucleus that we just found somewhere? What would be the tendency of it? It would separate. It would explode. All the positive charges would repel each other. It would explode. What's keeping them together? The strong force. Okay, so the strong force is keeping it called the strong force because it's stronger than the electromagnetic repulsion. Okay, so these have to be precisely aligned so that things will happen. For instance, this chart, if you'll notice, it's a logarithmic chart that goes to infinity on both the x and the y axis. So this is a really big chart, huge chart. And in here is a little white sliver. That's the place that the constants need to be tuned to so that they could support life. Okay, so this is going out, it's fantastically improbable. Okay. So the point, and this is just an example of 2 out of 20, right? And the fine structure constant goes to like 7 other constants. They're all interrelated, fantastically complex, suggesting that as Fred Hoyle put it, that a super intellect monkeyed with the laws of physics. And he was an atheist. Okay.
So scientists who are atheists,
Yes.
when as Christians we look at this idea of universe having purpose, having a reflection of the creator, how are their arguments different? Are they simply materialistic kinds of arguments, or how?
Okay, so the question was, how do atheist scientists deal with this? And they deal, let me see what my next chart is. Okay, so they deal with it by saying that there's a multiverse and that there's basically a universe factory out there, and we just happen to be in one that worked. And so, as I put it at the bottom of this chart, William of Ockham, famous of Occam's razor, he would be puzzled by the fact that somebody saying that the reason there's one universe is that there's an infinite number of universes, and we just happen to be in this one. Okay, so I did a little calculation on this, on some of the odds, on another class I did on cosmic coincidences. And I figured that to get the fine tuning by chance that is represented by all this constants, it would be the equivalent of winning Powerball 5 times in a row. You know, and I think if somebody won Powerball 2 times in a row, there would be investigations, right? How did that happen? Okay, so anyway, so it's not convincing to say it was just an accident. And my argument summary thus far: our universe had a beginning. Matter, energy, time, and space came into being. They hadn't existed before. Logically, some entity outside of those that transcends those would have had to cause it. The universe was created in a dynamic fashion, further developing over time rather than a static doll's house of some kind. And then the controversy between entropy winding down and the building up of complexity. Several specific means were adduced to talk about how this added complexity was coming into being, even though it didn't have to be in the universe, and that the universe seems extremely fine-tuned mathematically, bolstering the idea that it was not an accident, and suggesting to some that it was made for purpose by some super intellect. What are your questions or comments? Michael. I can't understand you, I'm sorry.
Yeah, one was, I think you kind of answered it, but what was the case for the creator behind the Big Bang, or such physical start?
Yeah, I tried to cover that. The case for the creator was that it had to be some entity outside time and space that had access to an enormous amount of energy, and that presumably had some reason for wanting to do that. And
Another question was, are we going to put the presentation online?
you tell me, is this going to be on YouTube or something? Or?
We're not, we can put it on the website under the same name. We can put the size up.
Okay, so maybe that would be good. Otherwise, they can get in touch with me. I can share my slides. All right.
I just wanted to offer a posting on the church site. This really helpful to be able to go back to your slides and just review it. I like to do that. I like to get my points on the slides and then just kind of talk about them. But I think I try to have my argument, you know, like in order on the slides, pretty much. So thank you. We're just talking about them. We'll figure something out. David.
So it seems to me the Big Bang really offered a plus up for folks that were creationists. As soon as it developed over the last time. Before that, what was sort of the give and take between the two camps about, you know, you were sort of deciding how to argue the point of creation, other than the Bible. What would you point to? Now you point to say it was a Big Bang, something. What was it before that? What do you sort of point to other than religious arguments?
It would be religious arguments. So the question was, before the scientific argument for the Big Bang, what was the argument that creationists thought about for justifying that the biblical concept that the earth was created, as I understand your question. And so I'm reminded of the comment by somebody that, like, God said it, I believe it, that settles it, was I think the thing before but just looking at creation and saying that somebody was mentioning the beauty and everything of it. In the Bible, it talks about everybody's been reached by this appreciation of the world around them, and that the feeling that there must be some higher power that had to do with creating this. Sir.
Well, the Big Bang is something compelling, but the Big Bang and the quantum is so complicated, so counter to be a God. If God existed, why make it so complicated?
Okay, so St. Anselm talked about an argument for God and said, God is more wonderful than you can imagine. And so if God just, doing it this way is very impressive, and might be more impressive than doing it some other way. Sure.
The theory of the Big Bang, when did it occur? When was the theory accepted? Was it one scientist who came up with this? Was it a committee? Did it take time for this to be adopted?
Okay, so the question is concerning the Big Bang and when did the theory come about? And rusty on this, but the theory came about in the 1920s, I believe. And the idea was that Einstein's equation showed that the universe should be expanding. And then he fixed it. He put in another constant to make it stable over time. And he said that was his greatest mistake. But in the meantime, Hubble was noticing that the galaxies were receding, and that Eddington actually came, Arthur Eddington, the British scientist, noticed that the scientists were receding and that the universe was expanding, and that this priest, Dimitri, and another gentleman whose name escapes me, came up with a general idea that the universe had expanded from a very small point at the beginning. And Fred Hoyle came on TV and said, "You've got to be kidding me," or maybe it was the radio, and said, "You've got to be kidding me that this whole beautiful universe came out of some hot Big Bang." And so basically that christened it as the Big Bang theory when he was trying to put it down. But this all happened at I would say the mid-20th century, by the mid-20th century. And it was when the Hubble receding galaxies was more firmed up. And when I think when the engineers discovered the cosmic background radiation as predicted by theory, that was when the name brand scientists more or less said, whoa, there's something here that we agree with. Sir, let's see.
You commented on one of your slides, you weren't going to talk about alternatives. So I understand that that's fine. I would recall in one of your earlier presentations, you talked about multiverses. I was in a conversation a few weeks ago about multiverses as a way to understand cosmology. And I wanted to ask, are you going to address multiverses in a later presentation, or is this part of what you decided not to?
I'm skipping that today. However, if you were to Google my last name and God and Nature magazine, I've got an article in it about multiverses, in which I treat it more systematically. God and Nature magazine. Sir.
Yeah, I think after seeing some of the things that Hubble has sent back to Earth, that a lot of these modern day artists have a lot to learn yet from the creator of this universe and some of what you see there.
I agree, and that artists have a lot to learn from the creator, and that I'm drawn back to when I think John Glenn orbited the Earth, and one author said, all these guys with crew cuts and pocket protectors and slide rules have shown something to the rest of us about that they can, basically reach out and touch stuff that only philosophers had talked about in the past, and religious divines. It being about that time, I suggest and I look forward to continuing our discussion next time.